Imagine just walking up to a locked, completely impenetrable steel bank vault.
Right, like the kind that weighs tons.
Yeah, exactly. And without even breaking a sweat, you just reach your bare hand straight through the solid metal door, close your fingers around a gold bar, and pull it right out.
Which sounds completely impossible.
I mean, it sounds like magic, right? But the crazy thing is, in 4 dimensions, that wouldn't be magic at all. It would just be basic geometry. You wouldn't even be breaking the vault.
No, the vault would be perfectly intact.
And see, usually when we talk about existence or life and death, there is this expectation of absolute precision. It feels binary.
Yeah, it's a very on or off concept for us.
Right, like you have a heartbeat or you don't.
Yeah.
A tree is growing or it's just dead wood. We treat life and death as the most universal, unbreakable rules of reality.
Well, I mean, it provides a necessary comfort to think of existence that way. We naturally want to categorize the universe cleanly. We just assume that the rules operating right here in our immediate vicinity apply everywhere, across the entire cosmos.
But the moment you start digging into advanced theoretical physics, that clean categorization completely shatters. So today, we're unpacking a cosmological landscape that is genuinely mind-bending.
Terrifying might be a better word for it.
Truly terrifying, because we're asking a pretty huge question today. If time and space actually exist in multiple dimensions beyond just the 3 we can see and the one we experience as time, what do life and death actually look like?
Which is a massive question.
It is. Are these concepts universal constants, or are they just highly specific, local terms that only really make sense in our tiny 3-dimensional terrarium? So, welcome to the deep dive. We've curated this specific exploration just for you, relying on a seriously intense stack of sources today.
Yeah, we've got a lot of ground to cover.
We're synthesizing MIT lectures on relativity and Minkowski spacetime, advanced physics papers on Kaluza-Klein theory and brain cosmology, and some really dense mathematical treatises on higher dimensional geometries.
And to really grasp what life looks like in a higher dimension, we actually have to start by looking down at a lower one.
Right. So let's do a thought experiment. Imagine you are living your entire existence stuck inside the pages of a manga or an anime comic book.
So you are completely flat.
Exactly flat. You have length and width, but the very concepts of up and down do not exist in your universe.
This is actually the classic dimensional analogy. It was famously explored in this 1884 novel called Flatland, and it perfectly illustrates this idea of the perception gap.
A perception gap.
Yeah, because from our 3-dimensional perspective, we have a vantage point that grants us these seemingly godlike powers over that 2-dimensional manga world.
Because we are looking at their entire universe from an angle they literally cannot conceive of. Like, we wouldn't just see the outer drawn edges of a 2D character.
No, we would see everything at once.
Right. We would see their perimeter and their biological insides simultaneously. Like, I could look down at the page and actually see the food digesting inside a 2D stomach.
It's weird to think about, but yeah.
Or, tying it back to the bank vault analogy, if a 2D character locks a coin inside a square drawn on a page, that coin is perfectly secure to them.
Right, because there's no break in the ink line.
Exactly. But I can just reach down, pull the coin up into the 3rd dimension, and then just drop it outside the square. To the 2D character, that coin just teleported through a solid wall.
And what's fascinating is the math checks out perfectly on that interaction. To a lower dimension, a higher dimension always appears as magic or, impossible physics because their geometry completely lacks the coordinates to process the movement.
Oh, wait, seeing inside a drawing doesn't mean a drawing can actually be alive. I mean, biology requires complex systems, right? Even a really basic digestive tract in a 2D creature would just be a hollow tube running from its mouth to its end.
Which presents a massive structural problem.
Yeah, because a line drawn all the way through a 2D circle would physically cut the circle in half. The creature would literally just fall apart.
Yes, it would.
Plus, standard general relativity requires space to warp to create gravity, and a flat 2D plane doesn't have the depth to bend the way a 3D universe does. So how could a planet even hold together on paper?
Well, you've actually hit on the exact hurdles that made physicists assume 2D life was totally impossible for decades. But our sources include this brilliant 2019 paper by a physicist named James Scargill.
Oh, right, the Scargill paper.
Yeah, and he mathematically demonstrated that complex life actually could exist in exactly 2 spatial dimensions. He essentially solved the gravity problem by bypassing standard relativity entirely.
By using something else.
Right, he used a purely scalar theory of gravity.
Wait, a scalar theory, what does that mean? How does that replace the warping of space-time?
So think of a scalar field like a temperature map of a room.
Okay, a temperature map.
Yeah, at every single point in the room, there's a specific temperature value. It's just a number. There's no direction attached to it. In Scargill's scalar gravity model, gravity acts like that temperature map across the 2D plane. It allows for a simplified, localized attractive force between masses without needing all the complex multidirectional warping of standard spacetime. So mathematically, it proves a 2D sun could totally hold 2D planets in stable orbits.
Okay, so you have a flat planet. But what about the biology? What about the digestive tract cutting the creature in half? Or, like, nerves crossing over each other?
That's the other wild part. Scargill mapped out 2D biological networks and proved they could be mathematically complex enough to support functioning neural networks without paths ever needing to cross.
Wait, really? How do they not cross?
It relies on specific topological graphs. Basically, the nodes connect in a web-like structure along the edges rather than crossing through the center. So a functioning brain, capable of processing information and defining its own existence, could theoretically operate on a completely flat plane.
Wow. Which implies that life, as a process, isn't necessarily restricted to a 3D shape. It's just adapting to whatever geometry it's trapped in. So, if we are the gods looking down at a 2D manga world, processing all their insides simultaneously, what looks down on us? I mean, let's take that perception gap and apply it upward.
Well, the geometry scales up flawlessly. Just as you use your 2D retina to capture light bouncing off a 3D world, a 4-dimensional being would possess a 3D retina.
A three-dimensional retina. That implies they aren't just seeing a flat image of me.
No, definitely not.
Because if a 2D creature sees lines and we see 2D surfaces, a 4D creature sees solid 3D volumes instantaneously.
Right. With a 3D retina, a 4D entity looking into our universe sees the front of your face, the back of your head, the soles of your feet, and the biological inside of your heart beating all at the exact same time.
That is deeply unsettling.
It is. And the locked, solid steel bank vault is essentially just an open cardboard box to them.
Yeah.
They just reach through the fourth spatial coordinate, bypassing our walls entirely, and pull the gold bar right out.
So if a 4-dimensional object actually passed through my living room, my 3D retinas wouldn't even be able to process its true shape, would they?
No, you'd only see a cross-section.
Like if a 3D sphere pushes through a flat piece of paper, the 2D beings on the paper first see a single point appear out of nowhere. Then it expands into a growing circle as the wider parts of the sphere push through, and finally it shrinks back to a point and vanishes.
Exactly. By the same logic, if a 4D hypersphere passed right through your living room, you would initially just see a single point of light floating in the air.
And then it grows.
Yeah, that point would expand into a perfectly spherical, 3-dimensional glowing orb. It would grow to its maximum mathematical hyperdiameter, then shrink back down to a point and just pop out of existence.
And wait, if they exist physically, they must interact with light in their own dimension. When I stand in front of a lamp, my 3D body casts a flat 2D shadow on the wall behind me. Does that mean a 4D object passing by a 4D light source would cast a 3D shadow?
It absolutely does. The mathematics of dimensional projection guarantee it.
So I could be sitting on my couch, and suddenly a shadow appears in my living room. But it wouldn't be flat on the floor, it would have physical volume.
A physical, dark space.
Just a dark, 3-dimensional void taking up the space between my coffee table and the TV. That is genuinely chilling. It really implies that the perception gap literally defines our entire reality. We are only seeing the flattest, thinnest slice of an incredibly dense universe.
Which means we are entirely bound by the geometric limits of our biology.
Which brings us to the ultimate question of this deep dive. If these higher dimensions exist, does biology actually work out there? We just established 2D life could theoretically exist. Could a 4D or 5D biological creature actually be alive? Or is our 3D world the only place where chemistry fundamentally holds together?
The physics point heavily toward our universe being totally unique, actually, which brings us to the anthropic principle.
The anthropic principle, break that down for us.
Sure. It's the cosmological concept that the universe must be compatible with the conscious life that observes it. Because, if it weren't, we wouldn't be here to observe it in the first place.
Right, the universe has to allow for us, or we wouldn't be asking the question.
Exactly. And when we apply this to dimensions, we find that our specific architecture, what physicists call 3+1 spacetime, meaning exactly 3 spatial dimensions and 1 time dimension, is incredibly privileged.
Privileged meaning it's the only configuration where the fundamental forces of nature don't immediately self-destruct.
That's right. The sources outline exactly why biology fails outside of 3D space. Back in 1920, physicist Paul Ehrenfest mathematically modeled gravity in higher dimensions.
Okay, and what did he find?
Well, in our 3D world, gravity spreads out over the two-dimensional surface area of a sphere. This is known as the inverse square law. But if you add a fourth spatial dimension, gravity spreads out over the three-dimensional volume of a hypersphere.
So the gravitational pull dilutes much, much faster over distance. It basically becomes an inverse cube law.
Exactly. The drop-off is so violent.
So a planet straying even a millimeter off its orbital path would either completely lose the sun's grip and fly into deep space, or immediately spiral inward and incinerate.
Yes, stable solar systems are physically impossible with more than three spatial dimensions. And the structural failure goes all the way down to the atomic level, too.
Oh, really? Even atoms fall apart.
Yeah, in 1963, physicist F.R. Tengerlini demonstrated that the same extra dimensions completely destroy quantum mechanics.
Because the electromagnetic force holding an atom together behaves just like gravity, right? It would dilute too fast. The centrifugal force of an orbiting electron wouldn't be able to find a stable balance point with the pull of the nucleus.
That's it, exactly. The electron orbitals completely collapse. The electrons would either scatter out into the void or crash directly into the nucleus. And without stable atoms, you simply cannot form molecules.
No chemistry at all.
Right, you cannot have carbon chains, DNA, or any biological mechanism.
Okay, so higher dimensional life is definitively out. But what about the other side of the debate? We discussed Scargill's theoretical 2D life earlier, but not all physicists agree with him, right?
Oh, far from it. Physicist Max Tegmark strongly challenges the 2D life model. He argues that even if you can mathematically map a neural network on a flat plane without crossing lines, the restriction is just too severe for complex consciousness.
Because in 3D space, your blood vessels can go over, under, or around your nerves.
Exactly. It allows for massive density and complexity in a brain. Tegmark argues that restricting matter to a 2D plane makes complex, conscious brains practically impossible to evolve naturally.
Wow. So life really isn't a universal rule. The concept of being alive isn't some cosmic standard. It is a hyperlocal phenomenon. It relies entirely on the precise geometry of three spatial dimensions to physically hold matter together.
It's very fragile when you think about it.
Extremely, but life isn't just a static shape. It's a process, right? You are born, you exist, you decay, and a process needs time. That's the +1 in the 3+1 terrarium.
And altering that +1 dimension is just as catastrophic as adding space. Calculations actually show that if a universe had 3 dimensions of space but 2 dimensions of time, causality would completely disintegrate.
2 dimensions of time? I can't even picture that.
It's chaos. The mathematical behavior of physical systems becomes entirely unpredictable. You literally couldn't define a before or an after.
And what about the matter itself?
It falls apart.
Yeah.
Fundamental particles like protons and electrons become unstable in multiple time dimensions and rapidly decay. Matter would simply dissolve.
Okay, so if life as a physical construct absolutely requires this strict 3+1 geometry, what about death? Because death is entirely dependent on time passing. We exist, the clock ticks forward, we stop existing. How does the physics of time dimensions change the definition of death?
To really understand death in physics, you have to look at how relativity models our reality. We exist in a fused four-dimensional continuum called Minkowski space.
Minkowski space, okay.
In this model, your life is not a sequence of fleeting passing moments. From birth to death, your entire existence forms a solid geometric shape stretching through space-time. Physicists call this your world line. And this world line is constructed out of events.
But a mathematical event isn't an ongoing thing, is it? It's not like a concert or a birthday party. It has absolutely zero duration.
Correct. Zero duration.
It is a single, infinitesimally small point mapping a specific location at a specific microsecond in space-time.
Now, the geometry of Minkowski space categorizes the separation between any two of those events into two main types. They're either time-like or space-like. And this is where the standard definition of life and death gets completely bizarre.
Bizarre how?
Well, if two events are space-like separated, it means they are so far apart in space that not even light could travel between them before they both occur. Because no signal can possibly connect them, Their chronological order depends entirely on the reference frame of the observer.
Let me make sure I'm mapping this right for our listeners. If events are space-like separated, does that mean, depending on where an observer is standing in the universe or how fast they are moving, they could literally watch a person die before seeing that person being born?
The math permits exactly that for space-like events. An observer in one galaxy might see an event happen before another, while an observer flying past them in a rocket sees the exact same two events happen in reverse order.
That's wild, and neither of them is wrong.
Neither is wrong. Time is entirely relative to their specific frame of reference.
Yeah.
However, the caveat here is that an individual's actual biological life operates on a time-like trajectory.
Meaning my birth and my death are connected by my physical body moving through space slower than the speed of light. That's my world line.
Exactly. For your own time-like world line, causality is strictly preserved. A cause must precede an effect. You will never experience your own death before your birth, and you cannot step backward along your own timeline.
But time is still relative, which is where the mind-bending reality of time travel comes into play, doesn't it? Because even if I can't go backward, my speed through the universe dictates how fast I approach my death compared to everyone else.
Yeah, the MIT course notes on relativity detail this beautifully through the concept of proper time. When two observers are moving at different speeds, they experience different lengths of proper time between the same two events. This leads to the principle of maximal aging.
Maximal aging, it sounds like something you definitely want to avoid. You want minimal aging.
Right. Well, in relativity, an unaccelerated object, so something just floating freely through inertial space, actually experiences the maximum amount of proper time. It ages the most.
So standing still makes you age faster.
In a sense, yeah.
Yeah.
If you apply force to accelerate, say you get in a rocket and zip around the solar system at near light speed, your path through spacetime curves. You deviate from the path of maximal aging.
Because I'm trading movement through time for movement through space.
Exactly. Because you are making that trade, your clock physically slows down relative to the rest of the universe. You literally age less.
This is the classic twin paradox. I go to space, fly around extremely fast, and come back. To my biology, maybe 1 year of proper time has passed. I am 1 year closer to death. But to the rest of Earth, decades have passed. Everyone I know has lived their entire world lines and died.
Yep, you've outlived them all.
I have technically time traveled into the future simply by manipulating my velocity through our 3+1 dimensions. So death is inevitable on my personal world line, but when my death occurs relative to the universe, is completely flexible.
Your world line took a geometric shortcut through the Minkowski continuum. The biology of death remains the same, but the chronological coordination of it is entirely subjective.
So physics basically proves biology demands exactly 3 spatial dimensions, and our experience of time is completely relative to our speed. But wait, string theory and M theory, which attempt to unify all of physics, famously demand 10 or 11 dimensions for the universe to function mathematically.
Right, up to 11 dimensions.
If these extra dimensions exist, but we can't biologically exist in them, and we obviously can't see them, where are they hiding?
Physicists have 2 primary mathematically sound models for where the extra dimensions are hiding. The first is Kaluza-Klein theory, developed back in the 1920s, which proposes that the extra dimensions are compactified.
Compactified, meaning they are curled up into microscopic spaces.
Exactly, curled up down to the Planck length. And to give you a sense of scale, the Planck length is about 100 million trillion times smaller than a single proton.
That is incredibly small.
It is. Imagine an acrobat walking on a tightrope. To the acrobat, the rope is essentially a 1D line, right? They can only move forward or backward.
Okay, yeah.
But to an ant crawling on that same rope, it's 2D. The ant can move forward, but it can also crawl around the circular circumference of the rope. Kaluza and Klein suggested the extra dimensions are like that circumference. They're curled up so incredibly tight that our large 3D matter cannot perceive them or move through them.
It's like trying to fit a bowling ball into a microscopic pore on a sponge. It physically doesn't fit into the dimension. But there's a second theory in the sources, right? Brain cosmology. And I'll be honest, this one sounds terrifying.
Oh, it is. Brain is short for membrane. This model suggests that our entire three-dimensional universe is just a 3-brane. Basically a thin 3D sheet or shell expanding inside a vastly larger, higher-dimensional void called the bulk.
So we are literally drifting inside an 11-dimensional room. We just can't see the room. Why are we stuck to the wall? Why can't we step off the 3-brane into the bulk?
It's because of how the fundamental particles building your body function in string theory. The electrons, quarks, and even the photons of light you see with are modeled as open strings.
Open string.
Yeah, think of them like tiny guitar strings with two distinct ends. The math dictates that the ends of these open strings are permanently anchored to our three-brain. We physically cannot leave the 3D surface because the microscopic building blocks of our atoms are glued to it.
Wow, we are quite literally trapped on the painting. But if we're completely glued to the three brain and light can't escape it either, why does the bulk even matter? Do we interact with the higher dimensions at all?
We interact with them constantly, actually, through gravity.
Just gravity.
Yep. Unlike electrons or light, gravitons, which are the theoretical particles that carry the gravitational force, are closed strings. They look like tiny rubber bands. Because they have no open ends, they are not tethered to our three-brain.
Oh, I see where this is going.
Gravitons can freely vibrate off our universe and leak out into the higher dimensional bulk.
Wait, is that why gravity is so incredibly weak? I've always wondered why I can pick up a paperclip with a tiny, cheap fridge magnet, and that tiny magnet completely overpowers the gravitational pull of the entire mass of planet Earth.
That is exactly the mechanism brain cosmology proposes. Gravity seems weak to us because we aren't feeling its full force. The bulk of its strength is literally bleeding out of our dimension into the extraspatial dimensions.
Oh, that is incredible.
So while we can't comprehend or biologically survive in the bulk, our universe is securely tethered to it gravitationally.
This entire deep dive completely shatters the way we look at existence. We started by exploring how life could adapt to a 2D scalar gravity field, operating as a flat neural network.
Which challenged a lot of old assumptions.
Definitely. Then we deduced how a 4D entity could pierce straight through our biological insides and cast 3D shadows in our living rooms. We unpacked the anthropic principle, proving that the inverse cube laws and atomic collapses of higher dimensions make our stable biology entirely reliant on this highly specific 3+1 terrarium.
We are very lucky to be here.
Very lucky. And finally, we saw how the flexible geometry of space-time turns the process of life and death into relative coordinates on a world line.
Which really brings us back to the Minkowski space-time model, and perhaps the most profound realization in all of physics.
What's that?
Well, if space-time is a fused four-dimensional block, meaning if time is just a structural coordinate like length, width, and height, then the entire timeline already exists.
Like the finished manga comic book we talked about earlier.
Precisely. The book is already printed. Every single event in your life, from the exact moment of your birth to the specific microsecond of your death, is permanently embedded in the geometry of the space-time continuum.
So it's all just there.
Yeah. From a four-dimensional perspective, you aren't a biological machine moving forward, making real-time decisions. You are a static, unchanging four-dimensional structure. Your beginning, your middle, and your end are all equally real, and they are already there.
Which leaves us with a genuinely terrifying puzzle for you to chew on. If the ink is already dry on the page of space-time, and your entire world line is a fixed shape sitting in the bulk, what does that mean for your free will tomorrow?
It's a huge question.
Are you actually making a choice, or are you just observing a geometric shape you are permanently trapped inside? That is a heavy thought to sit with today. Keep exploring, keep questioning the frame of reference you've been given, and most importantly, enjoy the rest of your coordinates on your world line. Thanks for joining us on this deep dive.